Okay, I hope all of you have joined the class again. Uh, I was explaining to you the lead silver system. Lead silver system is an example of two component system. This lead silver system consists of three phases, and the three phases are namely solid lead, solid silver, and solution of silver and lead. Okay, and to explain the composition of each phase, we need two independent chemical constituents, and that are lead Pb and silver Ag. Okay, without these two chemical constituents, we cannot define the composition of each phase. Therefore, it is said to be an example of two component system. When we look at the phase diagram of the lead silver system at a glance, then easily you can divide this phase diagram in different parts, and these different parts are regions, curves, and eutectic point C. Okay. Uh, if you observe the figure carefully, then you will observe three different types of areas. Okay, the area above ACB, here the solution of lead and silver system is has a stable existence. The area below ACD has solid lead, and the area below BCD, here exists only solid silver system. Okay, now when you got to know the area, okay, above area, the area above ACB is nothing but the existence of molten form of lead and silver. Okay, here only one phase is existed. Here only one phase is existed, but it is number of components are two. Now, uh, to explain, to determine the degrees of freedom of two component system, as it is said to be the solid liquid equilibria, we know that the Gibbs phase rule is given as F is equal to C minus P plus 2. Okay, Gibbs phase rule is given as F is equal to C minus P plus 2. F stands for degrees of freedom, C stands for number of components, and P stands for number of phases. But since the lead silver system is said to be solid liquid equilibria, because there exist only two states of the, or out of these three, only two phases exist, means vapor phase does not exist. Here we cannot take the third variable, that is third variable, three variables: temperature, pressure, and concentration or composition. Since here in this case, in this example, vapor phase does not exist, so the Gibbs phase rule is reduced to the equation as F is equal to, it is very very important, please students remember it. Gibbs phase rule, since the vapor phase does not exist, so the condensed or reduced phase rule has to be used to determine the degrees of freedom. समजलं का? तिसरी phase जे की vapor phase आहे, you will not observe the vapors of lead, neither the vapors of silver. Therefore, vapor phase, we can say it does not exist in this system. So, reduced phase rule can be used to determine the degrees of freedom. Okay, and that reduced phase rule, or it is also known as condensed phase rule, which is given as F is equal to, I would try to type here the reduced phase rule. This, is it possible for me to text anything on the, okay, reduced phase rule. Okay, F is equal to C minus P plus 1. Okay, this is called reduced phase rule or condensed phase rule. F is equal to C minus P plus 1. Okay. Now, students, when you got to know in this area only one phase is exists, that means number of phases 1, number of components 2. 2 minus 1 plus 1. What is the answer? Who will tell me?
2.
Number of components 2. 2 minus phases 1 plus 1.
2.
1.
Yes. Number of components 2 plus 1 3. 3 minus P. 3 minus P. Number of phases are only 1. 3 minus 1 2. Therefore, degrees of freedom is equal to 2. But that what does it means? To fix the any point we need to fix. Okay, degrees of freedom 2 म्हणजे काय? To define the composition of any phase, we need to fix the composition as well as temperature. These two variables we are using in this lead silver system. In the water system, we were using temperature on the x-axis and pressure on the y-axis. Since the vapor phase does not exist in this case, therefore temperature is taken variable. Temperature is also variable and the composition is also variable. Now, okay, to means this each region or each area has how many degrees of freedom? 2. Okay, this region also has 2 degrees of freedom. This region is also has 2 degrees of freedom because each area represents only one phase. Each area represents only one phase, and to explain the composition of each phase, we require at least 2 degrees of compounds, 2 degrees of 2 chemical constituents. Therefore, each area has 2 degrees of freedom. Now, while moving to the curves, if you observe this diagram carefully, you will find only 2 curves, curve AC and curve BC. Okay, and to explain this curve, I would go to the next slide. Okay, if you look at the figure carefully, only you will have this curve AC and curve BC. Now, curve AC indicates, okay, if you look at this figure, this curve AC, along this curve, below this curve, solid lead is present. Above this curve, solution of lead and silver is present. That means it represents, the curve AC represents or shows or exhibits what? The freezing point of solid silver. This curve curve AC represents the freezing point of solid lead. Freezing point of lead, or we can say melting point of lead also. Freezing point and melting point are nothing but the same. Okay, nothing but the same means the temperature at which liquid freezes and the temperature at which solid melts. These are the two different. What is the first point to explain the curve AC? Curve AC indicates the freezing point of lead with the addition of silver, in which the point A indicates the freezing point and of pure lead. काय म्हटलेलं आहे? The curve AC represents the freezing point of lead. ह्या leadचा freezing point, leadचा freezing point with the addition of silver. Okay. ह्या बाजूला, if you look at this G and H point, at G point there exists 100% lead. म्हणजे ह्या साइडला leadचं प्रमाण जास्त आहे आणि at the right side of this phase diagram there exists a stable existence of leads, solid silver. Understood? On the left side there exists lead, on the right side there exists solid silver. Okay, along this curve AC this curve AC represents the freezing point of lead on the addition of silver. आपण जर पाहिलं तर हे टेम्परेचर काय आहे, on the y axis temperature is taken. Okay, when we move from G to H point or lead to silver, that means when we move from left to right, the composition of silver increases and composition of lead decreases. Okay, इकडून इकडे जाताना लेड हळूहळू त्या सोल्युशन मधून कमी होत जातो आणि सिल्वरचं प्रमाण वाढत जातं. And at the extreme right, there is a 100% silver. On the extreme left, there is the existence of 100% lead. Okay, 100% lead. That means AC represents the freezing point of whom lead. Yes, add Mayur, please unmute yourself. Mute yourself. Okay. Okay. Melting point. म्हणजे आपण इथं जर थोडंसं सिल्वर, इथं काय आहे 100% लेड आहे. Okay, here at the point G there exists a, or at the point G there exists a 100% lead. But if you add some quantity of silver, म्हणजे इकडे उजवीकडे मूव्ह होणे म्हणजेच काय, ऍडिशन ऑफ सिल्वर. If you add some amount of silver to this lead, then the freezing point of, इथं ह्या पॉइंटला आलं समजा आपण, ह्या पॉइंटला, तर काय होईल इथं, if we add silver, then freezing point इथून इथं आला, डिक्रीज झाला का इन्क्रीज झाला? Yes, temperature increases in upward direction, but that arrow slightly slanting towards the x axis, that means temperature decreases. म्हणजे the एक point लक्षात ठेवा, the curve AC indicates the freezing point of solid lead on the addition of silver. Or in simple words, if you do not understand this statement, then remember that the curve AC represents the effect of addition of silver to the lead on the freezing point of lead, on the freezing point of lead. म्हणजे लेड मध्ये सिल्वर ऍड केला तर लेडच्या फ्रीजिंग पॉइंट वर काय परिणाम होतो हे आपल्याला या कर्व एसी च्या सहाय्याने एक्सप्लेन करता येतं. आणि ॲट अ ग्लान्स वी कॅन predict that on the addition of silver to the lead, freezing point of lead decreases. Just remember, on the addition of silver, the freezing point of lead decreases, that represented by the curve AC. And the point A represents the freezing point of lead. You need to remember, remember this temperature. Okay? You have to remember, just A point in the lead silver system represents the freezing point of lead, which is equal to 327 degree Celsius. Okay, and another curve BC. Okay, first the curve AC represents the effect of addition of silver on the freezing point of lead, as well as along this curve two phases exist in equilibrium. And which are these two phases? One is solid lead, another is solution of lead and silver. Therefore phases are two, number of components are also two. Then what is the degrees of freedom? Yes, काय आहे degree of freedom? C is equal to 2, P is equal to 2, therefore F is equal to, yes, who will tell?
1.
Very good. Yes, number of degrees of freedom is equal to 1. That means along this curve कुठलाही एक पॉइंट फिक्स केला आपण इथला, कुठलाही एक पॉइंट फिक्स केला तर काय होतं, हा पॉइंट आपण इथं फिक्स केला, ओके, या कर्वचा, तर याचं करस्पॉन्डिंग टेम्परेचर जे असेल ते असेल. हे जर एकदा फिक्स झाल्यावर ऑटोमॅटिक त्याचं कंपोजिशन देखील इकडे फिक्स होतं. म्हणजे इफ यू नो द कंपोजिशन यू कॅन प्रेडिक्ट द टेम्परेचर ऑफ दॅट सिस्टीम, और इफ यू नो द टेम्परेचर यू कॅन प्रेडिक्ट द composition of that system. degrees of freedom 1 means even if we fix the value of one variable, the other variable automatically get fixed. Okay, this is about the curve AC. And what about the curve BC? This curve BC represents the freezing point of silver, and it also shows the effect of addition of lead. आता इकडे उजवीकडून डावीकडे जाताना काय ऍड करतो आपण? उजवीकडून डावीकडे वी ऍड लेड. इथं काय 100% सिल्वर आहे. इकडे जर आलो तर इथं थोडं जास्त प्रमाणात लेड, इथं जास्त, इथं जास्त. अशा पद्धतीनं लेड इन्क्रीजेस, द percentage of lead increases from right to left, and percentage of silver increases from left to right. This curve BC indicates the freezing point of solid silver, and it shows the effect of addition of addition of lead minimizes the freezing point of solid silver. Okay, along this curve also two phases exist, therefore two phases, therefore number of degrees of freedom is equal to 1. Therefore we can say on this curve also, if we fix any point, if we fix any point if we fix any point, the other variable can automatically be predicted. Other variable can automatically be predicted, or its value get automatically fixed. And the last portion of this system is the eutectic point. The eutectic point, the point where all the three phases, किंवा आपण असे डिफाइन करू शकतो आपल्याला, the eutectic point in the phase diagram is the point where the curve AC and curve BC meets, where all the three phases exist in equilibrium. म्हणजे या फेज डायग्राम मधला असा एक पॉइंट जिथं कर्व AC आणि कर्व BC जॉईन होतात आणि तिथं तिन्ही फेजेस एकमेकाच्या इक्विलिब्रियम मध्ये एक्झिस्ट राहतात. ऑल द थ्री फेजेस एक्झिस्ट इन इक्विलिब्रियम विथ ईच अदर. दिस solution phase, solid lead phase and solid silver phase exist in equilibrium at this point. That is why it is said to be a eutectic. Eutectic means intersecting point where all the phases of the system exist in equilibrium. This is all about the phase diagram of solid lead silver system. It is all about the lead silver system. Now I request all the students, if you have any doubts, please raise your concern. If you have any doubts, you can ask me now. Yes, students.